Thank you for coming to our first webinar. A bit about me before we start. My name is Haley. I'm a field data scientist here at Arthur. And before that, I was a product data scientist at an ad tech company. So there I ran into a bunch of the issues of kind of productionalizing ML models and communicating my performance back. And now at Arthur, I kind of get to work on the technical success side of things. So helping other teams use Arthur to communicate back performance or improve the operations of their ML systems. And so in this talk, we're going to be talking a little bit about some of the best practices and lessons learned that we've discovered here at Arthur. And once again, noting that if you have any questions at any time, I believe everyone's muted just for like functionality purposes of the talk today, but feel free to drop them into the chat and it can be more of a discussion than even just a lecture through things. So starting off, it's kind of important to note that performance monitoring is not a novel concept. So most ML teams, if not all, have some way of reporting back what's going on with the model. And this is because businesses put models into production to achieve business outcomes. So there are very few business outcomes where people don't actually care to go back and understand whether or not it's working. However, even though so many teams have different ways of reporting back how performance is working, that does not necessarily mean that it is a solved problem. So when we talk to a lot of teams, we hear things in these major categories. So the first being that their systems may be more unstructured or that there's no organizational view of how the models are running in production. And this can mean that teams provide inconsistent metrics. Maybe external stakeholders don't really know what they're looking for, or like one team provides one metric and another team provides a different metric, making them unsure exactly what solid performance should even look like. Beyond that, teams get stuck where static files begin to get lost. So with the reliance on drowning in Excel sheets or transferring things into Excel macros, teams kind of figure out one way to make a report, but then as soon as they are in charge of transferring the report to a different section or making a different cut in the data, that may take longer. It may mean that a different view needs to be shared, or even worse, all of this could be stuck in institutional knowledge within one employee. And then finally, the most pressing one that we hear the most is that teams are unable to communicate ROI. And so no one wants to really work on anything that they feel isn't valued. So ML teams very much want to be able to communicate the return on investment of the cool things that they're working on. And business teams want to greenlight ML projects that are not only exciting uses of AI, but are also ones that they can report back and say, look at all of this value we've gotten from it. So both teams want this so badly, yet oftentimes they're just speaking in a different language to one another, which leaves both sides of the equation feeling incredibly frustrated. And so being unable to communicate that impact of ML models or translating ML metrics into a business sense kind of leaves everyone in this place where ML teams are really feeling as if they're not being heard. And so kind of here on the bottom, we have this idea that successful performance monitoring needs to support communication. And I think even beyond that, what successful performance monitoring really does is it empowers ML teams to feel ownership over their models and be kind of that point person in owning how they're going to communicate back to external stakeholders or owning that value that they're bringing to the company. And so one of the ways that a solution to all of those problems is, hint, hint, the tool Arthur, or the solution Arthur. But beyond that, even the best solution in the world can't function well in an organization without a strong workflow. So in practice, the way to bridge all of those gaps and kind of improve everything together is to put together a strong organizational workflow. And what goes into that workflow are actually, that's a little skip ahead, these three categories. So advanced performance monitoring, even though it's performance monitoring, so it's while the model is running in production, it actually starts during this experimentation phase. So it starts before the model is even put out or is being made, where teams can communicate with external stakeholders to get a strong baseline of performance. It also requires different levels of analysis. So teams have to be able to quickly own the communication back for any segments within the data that they're looking for, or like the different levels of granularity required. And finally, it needs to fit into production constraints. So while both of those are constraints that happen during the entirety of the ML lifecycle, performance monitoring in practice happens after the model has gone into production. So teams have some other things that we're going to cover today that they have to keep in mind when actually releasing and communicating back that performance. So first things first is that it starts during experimentation. So I kind of went over this in the overview, but what experimentation is it's when teams are still building up different types of ML models. So maybe you have the business level use case that you're looking for. So that could be a credit card fraud model, but you're looking at a bunch of different model architecture types, or some different hyperparameters, or you're using an experimentation tracker like MLflow to keep all of that together. One of the things that teams can do actually during this early phase to set themselves up for success later on in the monitoring phase and beyond is to work early with external stakeholders to define success for them. So one of the main ways that we see this is by asking ML teams how they define success. Oftentimes that'll be things like traditional metrics. So maybe that's, oh, this model will be successful if it beats the accuracy rate or the F1 score of the model that's currently in production. However, if those teams start to talk to other external stakeholders, maybe the product teams have a different way of defining success. Like maybe they're like, okay, if it's accurate, even if it's a little bit less accurate, like people are still clicking on the ad or they're still buying the product. But what we really care about is like latency, or how fast back can people get like feedback, because otherwise like maybe they'll click out of the app. And like we care about how long people are spending inside the app. Well, the business impact might be more about are people purchasing more or less expensive items. And so when teams communicate early, they can even incorporate some of these business metrics into their experimentation. And they also kind of prep their arsenal early on for conversations that they'll have later with those teams when they start like communicating performance back. So they can say that these are some of the metrics that we care about, and this is why we think that these metrics matter for you. Beyond that, the next phase of ML development is validation. And in validation, that's when teams kind of validate what is the winning model of experimentation, or validate a model to be ready to go into production. And this is incredibly important for performance monitoring, because this is when teams define what success actually looks like. So in experimentation, we had a lot of metrics that we were choosing between, and a lot of like competitions between models of being like, oh, is this one better? Is this one better? And things like that. But in validation, we say that this is an acceptable rate of success for the model to be running in production. And so once we get that level of acceptable performance and get feedback from external stakeholders, from the team themselves, we've kind of set a baseline for production monitoring that we can communicate back or prepare ourselves with. And so these are kind of that preparation phase of being ready to communicate performance back and prepping your arsenal as a team. After this, we also know that successful performance monitoring requires different levels of analysis. And so what we mean by this is teams that are very successful in empowering their data scientists to be the core communicators of model performance are also teams that empower those data scientists to pull data fast and quickly, and also make it very pretty. So external stakeholders may expect a consistent report or some sort of feedback, which is great. And typically those tend to be these like higher level aggregates. So that'll be a dashboard that they look at weekly, or descriptive statistics of like how well is the model performing, like what's my accuracy rate. But to actually empower teams to own that responsibility of their model performance and kind of like be the point person in the organization, they also need to be able to easily explore segments of the data and also extract key insights. So you like promote confidence in yourself as a data scientist when people can ask you a bunch of questions and you can easily pull up the data and make it something where it's external facing and ready. So there's a lot of like matplotlibs that I've sent out in my day that may not have been as externally facing and ready, but like easy to pull. But when you have a way to like quickly and easily segment and answer questions in a like professional, visible way, that definitely allows data scientists that ownership over like easy communication. And so with that ramble, we are going to take a quick look at kind of what these first points of performance monitoring actually look like in the Arthur platform, and talk through that a bit. So if anyone has any questions also at any point during this demo piece, please feel free to send them along in the chat. But with that, I'll go into the demo environment. So this is our Arthur demo environment. We're going to skip over actually this first control panel homepage. So due to the shorter aspect of the webinar today, we won't get into everything, but here we can see our model homepage. So one of the ways that this kind of single pane of glass look into all of the models that you're running in your organization can be helpful is that it provides that consistency to external stakeholders. So no matter what type of model you're running, like whether that is, so you can tag it different things, but whether that is a model of a specific input type, whether that's tabular, NLP, or image, any different output types that we support, you can save that model in Arthur, and it kind of gives external stakeholders that ability to understand and already be familiar with the format that you're going to send graphs to them, or like some of the metrics that they should be prepared to look at. And that empowers data scientists to be able to easily communicate that back. Next, we can go into this performance overview for one of our demo models, credit risk. So this is a model that is determining whether or not a credit card has fraud. And so it's a binary classification model. And so in here, we can see a quick look at all of the different levels of performance that data scientists can easily see. So they can select different metrics and pull them up on the graph, as well as segment between things. So if we wanted to there we go. I just had to hit refresh. I got a little nervous. But so here we can see different performance metrics. And so in the, how do we set thresholds on performance metrics? Okay, perfect. Thank you. I was looking for a question. But so currently in the UI, you can see that there is a threshold based on your reference data set. So your reference data set is something that we will talk about in the next section, but it's basically a baseline data set of what your model believes to be like normal. And so we'll talk about that when we get into data drift and some production constraints, but you can easily baseline then all of your graphs based on the reference data set and see them right here. Also, we are not going to get into alerts too much today, but in the alerts section, you are able to create and manage alert rules. So what alerts do in Arthur is they allow you to get immediate feedback based on, or not immediate feedback, but like send yourself messages based on how your model is doing. So monitoring is all in well, but if you don't know to actually look at your model, you won't ever actually monitor it. So alerts are a very important piece of that. And I'm sure that we'll do a different webinar for them upcoming. But each of our alert rules are based on different thresholded metrics. So you can create both a warning and a critical alert on any threshold for any metrics that you want to look at, whether that is a metric that you have here in the UI or a custom metric that you are building based off of our query engine. And so those are kind of two of the ways for doing thresholding or like setting that barrier in the UI itself. Beyond that, I also wanted to get into some segmentation things. So you can easily segment based off of different categories within your data. All of these are kind of not as intuitive of categorical labels, but this allows you to easily segment and send off data that people are, or graphs that people are expecting if you get asked questions. You also can quickly filter and look through any of the global filters that we have, and these will just filter the entire graph for that, or the entire platform itself. So any inferences that you want to go into, insights, or graph overviews. Beyond that, I do want to just give a quick mention. We will do a fairness demo later on, because there are a lot of ways in which we help teams operationalize fairness for their models. But that is one of the most popular ways that teams want to segment and look at different trends. So typically, fairness is done for sensitive attributes. So we allow the addition of non-input attributes into the platform. Those are features that weren't necessarily a part of your model, but allow you to track them still. So say for each inference, like, you know, the like sex, age, like race, gender of the person that you're predicting for, we don't recommend that you add that into your model so that you can track it with Arthur. Like, it may not need to be a predicted attribute, but you can still add that metadata about the inference so that you can track and segment the accuracy or any type of metric for them up here, as well as some of the most common fairness metrics that are in there. And in that, you can compare them against like a baseline group. So say we have male as our baseline group, we can see that even though there are some disparities in the exact accuracy, it's still within our fairness threshold that we've set. Meanwhile, for other ones, as our baseline group for education is less than high school, we have some disparate relationships or impact of how our model is predicting against those different groups. So for the sake of time, I'm going to go back into the slide presentation and hit some of these production level constraints. So it was kind of a quick overview of the first two sections. The third section is the ability to fit into production level constraints. So while the first two sections are questions or things you may need to be able to do that data scientists or ML teams are familiar with pre-monitoring or being put into production, a third major constraint that a lot of teams may not think as heavily about, or if they're just beginning to put models into production, or maybe running into a lot of issues with, are these actual ability to communicate back data based on production constraints. And one of the most common production level constraints that we see is the fact that many models in production actually do not get ground truth immediately, or in some cases ever. So that is what we talk about as a feedback loop. And so we can think about it in terms of a common example is home loans, where if you are running a model that is predicting whether or not someone will get a home loan, you won't know if that model is true until the model actually, until someone doesn't pay back on their loan, or until they have paid back on their loan. So that could be months, if not years. And so with that, typical ML evaluation metrics and business KPIs require a ground truth value. So when you think about model accuracy or F1 score, or any of the traditional metrics that you're familiar with, those typically require some sort of ground truth value. And so what we've seen is that in many cases, teams will use proxies for ground truth values. And so either that is a calculation that they're running and a proxy that they can put in, or they will use Arthur's data drift capabilities as a proxy for traditional performance monitoring. And so what data drift is it's a measure of how well the model was trained to understand the production environment that it's running in right now. And so with that, we take a look back at that reference data set that I mentioned before, that's kind of meant to be typical for the model. So that will be typically your training data set, maybe your validation data set, depending on those baselines that you want to look at. And it will be used as a way of comparison. So during that time, you validated your model and you said that this was optimal performance and this is an environment where the model succeeds. Now you can kind of look at your data and compare it back to then and see, is my data shifting it into an area where it is no longer set up for success? And so teams need to work early to communicate back on like what these proxies for accuracy are. So helping their external stakeholders understand what data drift is, as well as communicating back how they're going to use these proxies to drive actionable decisions. So in cases where you don't get ground truth, you may want to use metrics such as data drift to help drive these actionable decisions that typical performance metrics may help you do, such as when do you want to retrain the model, evaluating different upstream data issues or data pipeline inputs, as well as like looking into new features that may be emerging, like maybe a large drift means that you need to train a second model or evaluate things that are happening in there. So yes, so how does so I have two questions here and then I'll jump back into the platform. So the first is there a trial version? Yes, we are in actually for the second one, the Amazon Marketplace. So there is a 14-day trial there, as well as the ability to just go onto our website and click book a demo. And then you can work with anyone to get started on that. And then also, how does Arthur integrate into a production environment and experimentation environment, such as SageMaker to track and watch certain metrics? So SageMaker, we actually have an integration with. So that is our SageMaker data capture integration. We can, or potentially someone in the chat can send back a link to our documentation on that. But the integration into those environments is that Arthur is both model and platform agnostic, meaning that we integrate into anywhere that you are running models and any way that you are making models. So you just have to like send in those things, but for SageMaker, we do have that integration. So with that, I will quick hit into the platform again, just because I know we're running short on time. But so here's where we have data drift in the platform. So it's still the same model in the overview. And in this model, we actually saw, I'll clear all of the segments, that when looking at accuracy, there tends to be a bit of a drop over time. It's slow and stagnant, but it is starting to become substantial, especially with that final dip. And so one of the ways that teams may begin to investigate what's happening, other than just retraining your model and saying, okay, like accuracy's gone down, understanding what's actually happening is important to like report that back to external teams that may be wondering like what happened with the model. And so one way that we can do that is with evaluating the data that's going into it, or looking through each of the features. So I'll do that now. And so because it's the demo and I know a bit, I didn't have to explore it as much, but this is typically where teams will explore and begin to investigate their data. But here we can see that there is one feature that is drifting substantially. And so when we look at that, we see that that is our pay zero feature is drifting a lot over time compared to all of the other features. And then the next steps are actually right below it. So we recommend using drift with tabular models with explainability, and that helps you understand like what features the model is leaning on heavily when it's making predictions. And in this case, we can kind of see that that decay in accuracy is due to the fact that pay zero is a very important feature for the model. And with that, we would typically recommend probably a retraining. So retraining the model with more recent data there. But then we also can see how, in this case, what's happening, and potentially with someone on the data science team with more domain expertise about this credit risk model, you could see that it went from a shift from 0 to a lot more 8s. And so in this world now with a lot more category 8, our model is slipping it into an area where it is no longer performing very heavily or performing very well. And so we'd want to retrain it with more 8s and then potentially even begin to investigate like what is making that category 8 increase so heavily. Is it just a like slow drift over time, or is it something that we need to look at now? Perfect. And so we got some documentation for the SageMaker data capture coming in. But then, yeah, so this is kind of a overview of the different advanced performance monitoring workflow we went through today. So again, once again, performance monitoring begins throughout the entire life cycle of your ML model. So it begins when you actually begin experimenting. And so before you put your model into production, you need to work with the external teams to define what success looks like and kind of create that baseline of performance. After that, you need to prepare yourself with an arsenal where you can own the actual communication of the model, or like enable the ML team to own that. So that through that, you need them to be able to communicate effectively through granularity, whether that is in higher level dashboards or smaller reports, or being able to answer very specific questions about like fairness metrics or like even specific inferences. And then finally, you need to prepare your ML teams to be able to evaluate model assumptions continuously. So that means like even when you don't have ground truth, like using different proxies or like preparing external teams to understand like what types of performance we're going to be communicating back. And then finally, we didn't get too much into it, but Arthur does have the ability for you to actually label your data. So even if you don't get your ground truth right away, you can send in ground truth once you do receive it and kind of complete that feedback loop. So in that way, you are able to like eventually report back on the like maybe it's business KPI metrics or traditional accuracy metrics as well, all within the same platform. But with that, thank you for coming to our first webinar today. And if you have any questions, I am free to stay around and answer them, or also don't hesitate to get in touch. I know that we're coming to the end of the webinar now. So. Okay, perfect. We got one question. So it's thinking about systems that have no ground truth. One thing that comes to mind are teams that are trying to productionalize LLMs. So yeah, so we didn't go into the exciting new world of LLMs, but I'm not surprised that they've come up. How would you monitor generative models that wouldn't get ground truth? So that's an excellent question and most definitely top of mind. So there are a lot of models that actually may never get ground truth that aren't even just generative. So we can think of like we have a lot of customers that do computer vision or object detection. And so those are models where they would need to pay people to label the different bounding box metrics. I will say in the realm of generative, even getting a ground truth is hard in most times. Like the example that I use a lot is everybody grew up with somebody that said that math was their favorite subject in school because it has a definitive answer, you know, and we can kind of think of ML models the same way as like supervised ML models have a definitive answer. Like we can calculate accuracy, we can calculate F1 score or like balanced accuracy rate, but generative models are kind of, in a lot of cases, even those essay models, like maybe they're writing blog posts, maybe they're writing headlines or summarizing what's happening, but they are a bit more subjective. So teams need to look at things such as like tone or length or sentiment of the ML model, like not only an exact accuracy rate. And so I will say some of the things that we've seen for teams that are productionalizing LLMs are actually using metrics surrounding human feedback. So you can think about it as if anyone uses any sort of LLM where at the end, like maybe you get a thumbs up or a thumbs down based on like the user's experience. And that actually helps teams quantify how well the model is doing for the task it's set out to accomplish for that end user, and is actually one of the best ways for teams to communicate ROIs, like we believe as well, just because so many of those like generative model metrics are very in the weeds about like what the model is looking at. But yes, so I say that that is one of the most popular ways to do it.